So hey everyone, today we will be discussing problems on CODECHEF. So today was a contest on CODECHEF. I was able to participate in GIF 2 and I was able to solve 5 of them. Let's discuss the problems and the solution of them. Uh, so let's move on to the first problem. So the first problem says that, let me check that this is working fine. Okay, this is working fine. So the first problem says that there is each household. X is the mandatory water that is required by household per day. Y is the water that is not required much, means that it can be cut down to y by 2. And C is the capacity of the water, means liter of water that can are available for the entire land. So this is simple math problem. So here what we can do is we can calculate the value of water used per day and then multiply with the number of uh, what is this households, and then we can check if the water that we are wasting is less than equal to the number of the liter of water that is available. So let's come into the solution. So we are given each x, y or c. So we are using per day x plus y by 2. This is per day our uses, and in a week we are using used into each, and we have to check that if the number of liter of water that we are using is less than the available water. If it is, then yes or no. Okay, that was the first problem, pretty simple. So let's jump into the second problem. So the second problem says there are two groups, one of boys and one of girls, number from 1 to n, and here is a condition given that there is the likeness value. The likeness value is height of a girl plus height of a boy. So you have to form n couples, obviously, because there are n boys and n girls, so they will form n couples. In that n couple we have to find the maximum or likeness value of all the couples in minimum. So we have to minimize the likeness value such that the maximum will be minimum. So this is simple problem. Let's jump to solution. So what we can do is just we can sort the girls in ascending order. uh, Order and sorting the boys in descending order. So what will happen is that we are sorting the girls in ascending and the sorting the boys in descending. So for every couple, for every maximum there will be minimum available. So what I'm saying that suppose it is girls is like 0 1 2 3, and if we sort the boys in descending order like 3 2 1 0, so then here we can see that for every girl that is we are getting, for every minimum we are getting the maximum. So we are just like putting a maximum plus minimum, so to reduce the likeness value. So the most likeness will be 0. So let's run this. Oh, sorry, this 3. So maximum likeness is 3 because 2 plus 1 is 3, and also 1 plus 2 is 3. The maximum likeness that we can get is, and it is the minimum maximum likeness value that we can get. So let's move on to the problem C. The problem C is Gotham City. Oh, Gotham City is in danger. Batman have to arrive now. So Gotham City is in danger. All the people of Gotham are lifted. So what we are given here is we are given n, and we have given an array p. That is p is saying that the maximum number of people that can be put in this city. The maximum number of people that can put in 0th city is 5, 1st city is 5, and second city is 6, uh, and this is third city is 1. Oh, actually this is indexed one index, so this will be first, this will be second, this is third, and this is fourth. So let's take this example and let's try to get it understand what is happening here. So this is the example. So at first we are trying to put 11 people in second city, but here we can see that only 5 people can be put. So we are putting 5 people in second city, and then rest will be moved to the third city. So 6 people third city. Now the capacity of third city is 6, so it satisfied, and the total distance that is traveled is 6 people that have traveled a distance of 1. 6 multiplied by 1 is total distance. As 5 people have settled down in the city that where they have been put, so it is like here the distance travel is 5 into 0, it is equal to 0. Means they have not moved any distance, but 6 people have moved to the third city, so they have moved a total of 1 distance each, and there are 6 people, so there are total 6 answer. And in the second there are 3 people that are 3 people that are put in second city.
Here's something from YouTube.
That are put in second city, but we have seen that the capacity of now the capacity has become like this: 5, 0, 0, and 1, because they have already 11 people have occupied these 2 places. So we are saying that we are moving 3 people to second city, but they can't live there, so they are moved to the third city, but also there is no available space, so they move on to for the last city. So but only 1 people can stay there, and the remaining people have to die. So the total distance that is moved is 1 into 2. Answer is 2. 2 people have died, and only one people was able to go there, and he have moved a total distance of 2. So let's jump into the implementation. So what we can do here is like we can use a set of index and capacity. Means we are storing a set of pair index with capacity. So what we are doing for every query, we are taking x and k. We are providing k people to city x. So we will be doing this until k is greater than 0, until all the people are not settled. So we are searching for a index greater than the current greater than equal to the current city index, and we want to put no, means I mean no people there, -1. We are searching for a city that will be one available space will be available there for city that is greater than equal to the given index. So if we found a city such that the capacity is less than k, what we are doing is what we are doing here is the capacity of the city is less than the required value. What we are doing, we are adding the answer in the distance moved. The one d is the index of the city that we have found, and x is the current index that we are here. That will be the distance moved and into the number of people that were moving there. uh, Again we are subtracting the number of people that we have moved from k, and we are erasing that position f, because the iterator that is pointing at is now becomes 0. Means no other people can now go there, because they have, because every place on that is occupied. Now if c is greater than the k, what is means I mean c is the capacity of the index. If c is greater than that k, so what we can do is the number of people, number of distance is d minus x, as I already discussed, into k, means total people that will be moving is k, means because the remaining people is k, and we are erasing that iterator, and after that we are inserting something, because after placing all the k peoples there will be left something space, because at that place c is greater than k, so we are inserting c minus k there, and obviously we are setting k to 0. After that it will be, the loop will break. Suppose what if we not found, else if we don't find any place for the k people, then they are all going to die, and that's why we are breaking here. After that we are just printing the answer. So that's it. That is the simple implementation using set. Okay, hope you have understand the problem C and the solution. So let's move on to the problem D. So this got me some time, and this took me some time to do. Not obviously not so much time. So what we are given here, let's take this example. It will be better if I just draw this, because this is a what you say, it is a tree problem. So let's try to draw this. So we are given input 1 and 2 with length 10, 1 and 2, 2 and 3 with 20, so it is length 10. Here length means the distance between the two cities. 2 and 4 is 30. 2 and 4 is 30. And what next? 4 5 is 40. And what next? 1 and 6 is 50. So in the problem we said that this is the capital city, and capital city means this is the root of the tree, and we have to find the. So there are some pilgrims. So let me justify the question, make you understand the question. So there are m pilgrims with energy E1 to EM. So they want to move to city, special cities. So what are the special cities? Special cities are the ones that are only connected to one city. So here obviously what it means to say that these are the leaf are the special cities, because these are only connected to one nodes, and it is the root obviously. After this, so they are told that the energy required is to move from U to V is K into D. What is D? D is the number of district city that you have already visited before. So let make you understand with this problem. So suppose so these are the special cities where the pilgrims want to visit. So these are the special cities that the pilgrims want to visit. So the energy required to visit these cities 1 to 2 we are moving. So this is 1 into 10, and after this we are moving 1 to 20. So here the length length is 10 plus, no, length is 20, that is k value is 20, but d, what is d? D is the why it is written. I have just the total number of distinct city from the capital city to the city u. So distinct city, that means this and this. So the total cities, distinct cities is 2. So 2 into 20. This is length. So this sum will be 50. So the energy required to go to the city 3 is 50, and for this it will be 190. So you will calculate it, and for this it will be 50. So what we can do here is just DFS the tree. So let's see the implementation. So what we are doing is we are making an adjacency array of size is some constant number, and we are just clearing for every test case, and here we are storing the leaf, means the energy required to move to leaf, and we are making it clear for every test case, and we are storing the energy, and here we are storing u, v and k. Means we have to move u to v for with length k. K is the distance between the two cities. So we are just DFS doing the DFS with root 1 and minus 1 is the parent, 1 and 0. 1 and 0 is the city, number of city that we have, distinct city that we have visited, and value is the energy required. So here we can see that we have marked the last equal to true, because if something is going here, it is not the leaf, because if we go our level uh, uh, down, so it means that this is not the last, I mean this is not the leaf of the tree. So if leaf is true, then we are just putting the value, and value is of for every depth traversal we are doing, we are just adding the value with the number of cities that we have visited and distinct city that we visited with the value k. There is child of second is value k, and after we have got all the leaf values, that is the energy required to move to some cities, so we are just sorting all the leaf and all the energies, because for every leaf value we are just using minimum, we want to use the minimum energy required to get to the leaf. So here we are storing I and j equal to 0, and after that we are just iterating over I and j, and here we will be iterating until when the I is less than energy size and j is less than leaf size. If energy of I is greater than the leaf of j, what is mean that we have got a candidate, we have got a pilgrim for the leaf to visit, with the with that energy, and we will be doing plus plus and plus plus j, or else we have not got any that energy, and we will search further. So this is the complete answer. So let's move on to the final F problem. I was not able to do the E problem, as you can see the submission level is low. So after some time I found that f is being solved much, so I move on to the f problem. So let me drink some water. So what is happening here? Let's see. I will require this paint to make you understand how you can make. Don't see. So in a country stone line, there are n stone arranging left from right, and so let's take the example and try to make you understand what is happening here. So I have done with it a different approach. I have applied here LCA. LCA. So if you don't know about LCA, just check some channel of about LCA. You will get some videos, tutorial videos on YouTube about LCA. So what you can do here? 1 minute. Let me just get to the idea of how I will be showing you my approach. So let's take the example 3, 10, 20, 25, 10. 3, 10, 20, 20. Oh, sorry, this is 20, 20, 5, 10. So we are at, let assume that we are at the first position. So we can see this in increasing order, means it is the longest increasing subsequence starting from this index. So we can see this 3 to 10, then after 3, 10 to 20, we can see after 20 we can see. Oh wait a minute, this was not 10, this was 50. I think we can see this 50, because we can see this 20 because it is not in lexical here. I am sorry, I am extremely sorry. So as this 20 is not increasing, strictly increasing order, and here it is clearly said that max of that will be h of j will be greater than all the position behind that j. So here basically it means that we have to find the longest increasing subsequence, means strictly increasing subsequence. And after so that it can see 1, 2, and a total of 3. So it can see a total of 3 mountains, and 10 it can see 10 to 20, 20 to 50. It can show a total of 2 mountains, and for everything we can get it. So this was the basic idea. What the question is saying about. But there is a catch. They are saying that you will be given A and B, meaning 2 position you will be given, and you have to say that the total number of mountain that is seen by both. So let's suppose we are given A as this position, and what is example in the example? In the example it is 1 and 2, and B is given this position. So 3 can see 10. Make it clear. We can see 10, 20, and 50. This is already 50. But so 3 can see 10, 20, and 50. But 10 can see 20 and 50. 20 and 50. So the mountain that is seen by both is 20 and 50. 20 and 50, that is seen by both. So the answer is 2. And for every index, for every pair, we have to find the number of mountain that is seen by both. So the basic thing that I have done here is, let's I have made a graph, I've made a tree with with connecting the components like this. Means I have connected I have taken an infinity here. Let's make you understand my concept. What I have done here is, I have taken an infinity here. So this can see this infinity. From this tomato, this can see this infinity. 5 can see this 50. 20 can see this 50. 20 can see this 50. And 10 can see this 20. And 3 can see this 10. So I made a graph like this. Here it is. So I have taken number and m, and here I have taken the heights, and here it is infinity. The last index infinity. The last index in infinity. So I have used a stack to make this graph connected. So first I have put the infinity. Then after going from, I am traveling from backwards. So for every what I am doing is, while the topmost element is less than the current height, means I'm not going to look for the mountain that is smaller than or equal to my height. So we are just popping those heights, popping all with smaller heights, and then we are just connecting the two, that the the mountain that are greater than height of I. So stack dot top will be greater than that, and we are just connecting those two. After that, we are putting the stack element position in the stack. So here we are doing the LCA part with root. Root last index. So let me show you the example. So let's mark these positions: 0, 1, 2, 3, 4, 5, and 6, and let's make the tree. So here I am doing the tree. Here it is 6, it is the infinity. It is connected to 5. 6 is connected to 5. 5 is connected to 4. 5 is connected to 4. And what next? 5 is also connected to 2. 5 is connected to 2. What is this? 3. 3 is connected to 5. Okay, 3 is connected to 5. And what is this? 2 is connected to 1. 2 is connected to 1. And 1 is connected to 0. So this is the tree that I have got here. And now for every A and B, we can just find the lowest common ancestor, and we can then we can find the distance of that lowest common ancestor from the root, that is 6. So suppose the first example, it is given 1 and 2. As I have taken the index from 0, so it will be 0 and 1. This is the first example here, 1 and 2, position 1 and 2. As I have taken 0 indexing, so it will be 0 and 1. So 0 and 1 here. So its lowest common ancestor is 1, and the distance of it from the root is 1, 2, and 3. But here is the catch: the distance of it from the root is 3. What is the catch? Because it is because the lowest common ancestor is either equal to 1 or equal to is equal to 1, so we are not taking this one, so we are not taking this one, so we have to deduct a 1 from here, so the answer will be 2. And let's look at another example. Let's take this 4 4, so its proper indexing will be 3. So the lowest common ancestor of the 3 and 3 is 3, and its distance is 2, 1 and 2, but as it is equal to 3, so we are not taking this distance, we are taking only one distance. So this is the only thing that have to be done. So I will finding the LCA, and after the LCA is I am just taking the that if this LCA is starting from that position, if it is starting from that position, here it is checking that the LCA is neither equal to A and B, means the LCA is not equal to A and B, and if only that happened, then we are going to print the length of the lowest common ancestor from the root. Otherwise we have to deduct 1, as seen in the example. We have to deduct 1 because we are not taking this in account, and we are not taking this in account, so we have to deduct 1. Let's suppose the LCA, there was example, let me say 1 and 3. Yes, 4 5. So here it is 3 and it is 4, and here it is the let's make it clear. 4 and 3, 3 and 4. So here the 3 and 4 lowest common ancestor is this. So here the distance is 1. As this LCA is neither equal to A, this is A, and neither equals to B, so we are taking the distance as a whole. We are not subtracting 1 from it. So this is the common catch we have to do it. And LCA is the, and here is the full LCA part. You can get it from the CP algorithms website, and for calculating the length, I made my own DFS function here. So hope you have enjoyed the video and you have understand the questions and the solutions. Let's also I have scored rank 20 there, so this is my highest scoring till now, and I have got into the 3-star because earlier I have done, oh, my rating have increased 1950. Oh, that's great. Plus 169. Okay, that's great. So earlier I have done this silly mistake. I have in this April challenge 2021. If I have not done it, I will have been a 5-star coder now. Because I have done it, I have got very much minus, and I'm doing long challenges nowadays is very much frustrating because all the solution got uploaded on the YouTube. From now I will be skipping all the long challenges. Short contest will be the main target. So that's all for today. Hope you to see you on my next video. By the way, if you have not hit the subscribe button to my channel, please hit it. Please hit it. Please. Let's make 100 subscribers on my channel. Let's do this, please. So let's have a good night. We'll talk to you in another video. Bye for